Okay, it is a minute after the hour. We'll go ahead and get today's webinar started. So hello and welcome to everyone. Today's webinar is a real use case with NiFi, the Swiss Army knife of Dataflow. My name is John Silvers. I'm with Compose, and I'm one of the organizers for today's presentation. In a minute, I'll introduce today's speaker, Hayes Hutton, who is also at Compose. Today's call will be in listen-only mode. You can ask questions using the GoToWebinar panel on your screen, and we'll come back at the end of the presentation to answer any questions if there are any. We are recording today's webinar, and we'll send everybody who registered for it a link to the recording by the end of the week. I wanted to briefly introduce Compose for anyone who's watching who's not already a customer or who hasn't signed up for a trial. Compose makes it easy for developers to use production-ready databases for building apps without all the hassles of managing the databases. Each database is deployed in a high availability cluster, and what our customers tell us is that with Compose, they can focus on writing apps and not managing databases. We offer Compose both as a multi-tenant hosted service on AWS, Google Cloud Platform, and SoftLayer, and we also offer Compose Enterprise, which includes all the same goodness as Compose multi-tenant, but on your own cloud servers. We've been around since 2010. Back then, we were called MongoHQ, and about 2 years ago, we changed our name to Compose to reflect the fact that we host other databases besides MongoDB. We currently offer 9 different databases and developer services. We released MySQL about 2 weeks ago and launched ScyllaDB about a week before that. If you're not familiar with it, ScyllaDB is a drop-in replacement for Cassandra that boasts some very fast speeds without all the overhead that goes into managing a Cassandra database. So please go check it out and check out all of our services. If you're new to Compose, we offer everything free for the first 30 days. Okay, and with that, we're going to move to today's topic. Today's presenter is Hayes Hutton, who's one of the technical content creators here at Compose. He has also written a 3-part series on NiFi on our blogs at compose.com/articles. Just search for NiFi and you'll find them. As Hayes will show, NiFi is a really powerful tool for using data across data stores. Excuse me, and since many companies now routinely use 2 or more databases for running their apps, we felt this would offer some terrific insights into how to make the process even easier. So please be sure to post any questions for Hayes in the GoToWebinar questions box, and we'll get to them at the end. So with that, Hayes, I'm going to pass controls over to you.
All right, thanks, John. Hopefully my screen has come up.
Yep.
So we're going to get started here and move pretty quick. Again, thanks for everybody's time. I'm excited to share some insight into NiFi. It's a great tool that we're going to go over here, and I've got lots to go over, so I'm going to start moving pretty quick. And here we go. So to get started, I'm going to give an overview of what we're going to talk about today. So I've got a brief history and some context for NiFi. I'm going to talk about how it works with some of the main core abstractions, some of the things I think you should know about in order to actually be able to develop and utilize and know when to use NiFi. Then I'm going to build a simple flow, so the simplest of flows that I could come up with so that you would see what it takes and how easy it is. And then I've got a larger example already built, and we'll go through actually pulling some data out of some Twitter feeds and running it through a modestly complex flow and putting some data into going through Watson and doing some sentiment analysis, going into Redis, storing some scores for hot data, and then actually storing all of the data into Mongo. So kind of a complete flow of competitive intelligence data, as I like to call it, because we're going to pull Twitter feeds from different cloud competitors and then score the tweets. We're going to look real briefly at extending NiFi. One of the beauties of NiFi is that it's really customizable in lots of different ways. Today, we're going to even just look at extending NiFi with Node.js and some JavaScript, which is really pretty powerful, especially when it comes to prototyping and getting started real quickly. All right. History and context, some brief history in regards to NiFi. Where did it come from? NiFi was born in the NSA. So it ran, before it was turned over in the technology transfer program, ran in the NSA where they were utilizing it to obviously move data around. But probably bigger sets of data than a lot of us ever contend with. So it has an 8-year history before it was released into the public of running signal intelligence data flows in a really high volume environment. So NiFi can handle probably just about anything you could think of throwing at it. But as we'll look at today, too, one of the beauties of it is it even scales down to being able to run it on a laptop or a single server and doing plenty interesting information and processing that way. So it's based on a notion of flow-based programming. This is nothing new. It came out of flow-based programming started basically in the 70s, a paradigm that was created in the early 70s. It's really about defining an application as a network of black box processes with message passing connections. So what's interesting about that is you have a component model that doesn't know about the other pieces of components and everything's hooked up via a queue. You can actually create a full programming paradigm that way. So that's what NiFi does. When NiFi was spun out of the NSA, the team came out of the NSA too, and they were pretty quickly acquired by Hortonworks. So that's where most of the folks that have built NiFi reside currently. So it's still worked upon. Went to 1.0 out of the Apache project here probably just a couple of months ago. So Dataflow, I'm going to talk now, I'm going to change gears a little bit and talk about why you should use NiFi. So when it comes to moving data around, certainly you can build your own custom program that does such a thing. But once you really get into that process, one of the things that you start to find is there are a lot of features and functionality that you really probably shouldn't be developing, especially when a tool like a NiFi exists. And these are a few of them here that are core features that I think are really relevant, whether your data set is modest or whether it's really large. Guaranteed delivery. This core philosophy that everything needs to be delivered, and the infrastructure to do that through this persistent write-ahead logs and content repositories, which we're going to look at here in just a little bit. They're designed that they can handle the high transaction rates and the effective load spreading and copy on write content repository, and everything goes through on disk. So what's interesting about NiFi is as we build these flows, one of the things I want you to not forget is that this data is protected each step by step on the way, basically by a transactional write-ahead log that is managed in memory, but everything gets persisted to disk. Once the data comes into NiFi, it's persisted to disk. Once the data the metadata attributes that we're going to look at, they're persisted to disk too. So everything's protected through this entire flow. We're going to look at tweets, so whether tweets are really worth being protected is a good question, but there are plenty of situations where you really do want to protect your data. NiFi also handles data buffering, so this is another thing as you get multiple systems in place. So we're going to have a Twitter stream, we're going to have Redis, we're going to have Mongo. I mean, all of these systems are going to perform in different ways. Buffering and back pressure and all of these types of infrastructure is really important when you start mediating data between multiple systems. NiFi does it out of the box. You don't have to think about it. It's really pretty straightforward. You can do some prioritization of the data as it flows. This can be important for certain use cases. Obviously, the NSA probably had some of these. Also, there are a bunch of other dials that you can toggle and twiddle, like this latency versus throughput. You can do some loss tolerance if you got too much data and you don't want to, if you start getting overrun, you can drop data on the floor if you want to. But so that's all configurable, which is the way that it should be. So those were kind of the reasons to use NiFi. Now I'm going to jump into the main abstractions that I think you should know about as we look into some examples here in just a second. The core abstraction of NiFi is called a flow file, and a flow file is really nothing more than some metadata attributes, these key value pairs that as your piece of data flows through this data flow. The attributes help manage it. So a flow file is also a pointer into the actual content itself. So you can imagine if we're trying to manage millions and millions of records or tweets or whatever it is, we don't want to be copying that data around. So what NiFi does to solve that is they created this abstraction called a flow file. So the metadata can actually flow around through the system, and the content gets written once to a repository, and the flow file actually points to that piece of data. So when you start getting really big sets of data, that's really important. So NiFi throughout does things like that. The flow file processor, so processors are these little black boxes in the flow-based programming terminology. They're the only places that work is really done. So, this, like we'll look at, we're doing mediation between systems, so we'll pull data out of Twitter, we'll put data in Mongo. Each of those is a little processor, so it's a black box that performs functionality for us. These little black boxes are connected together via these connections, and all connections really is basically named queues. And these queues, we'll be able to look inside of these queues and see what's buffered up, and I'll do that on purpose in here because in just a minute, and we'll look at that actual flow file and see what's in a queue. All of that gets put in this flow controller, and a flow controller is basically the server itself. So it's going to manage what gets run when, threading of the processes, what gets put into a queue, the transactions, rights to the different repositories, and that type of thing. So those are kind of the main abstractions. They're still pretty abstract here since I haven't shown you any good pictures of them, but we'll get to that in just a second. One last architecture diagram because I think it's important. So NiFi is a Java-based program, which runs on the JVM. We're going to control NiFi via this web server. So that they deliver. So the entire interface of NiFi is delivered over HTTP. So everything that you look at here in a minute as I run a real live data flow will actually be done over a web server. And then the core of the server runs the processes and actually manages, that's what that flow controller is, and interacts with these repositories. And what's nice about NiFi is these three repositories, because these are kind of the three things that you really want when you have a data flow. So the flow file repository is a write-ahead log that manages key value pairs, which are the metadata of each piece of information that you have come into your system. So let's say I get a tweet. Tweet comes into NiFi, the first processor. A flow file gets written, and that's the data payload that gets written is the actual JSON text of the tweet. And we're going to see this in a second. But the attributes get written to this flow file, and they're kept in memory. So NiFi is going to write that once into the content repository, which is a read-only log of content. So if you change the content, it actually does a copy on write. So as you architect a NiFi flow, you really want to be conscious of how often you read and write content itself. Obviously, you want to try to get it into the metadata so that it's managed in the flow file. Provenance repository is a leucine-based index so that you can actually search for all types of audit-style information. So it's as this data moves through, each piece of data is tracked via this audit history that's searchable. So they've really covered all of the bases and have specific stores built up to handle each of the features that are necessary to do data flow correctly. All right, so the simplest of flows. Let's go ahead and build one. I've got a live NiFi up and running. We're going to build the simplest flow that I can think of. We're going to go out and we're going to get a web page, so this is kind of a source. It's going to create a flow file. It's going to drop it through this connection, which is called the success connection, and then it's going to go into another processor called put file. So this is a processor, this is a processor, this is connection. That's the simplest flow that I could come up with. So we're going to do that real quick and give you a sense of how NiFi works. So this is the NiFi canvas, that's what I call it. So this is kind of the whole control plane, the admin panel. Even users can come into this if you have it set up that way. These are process groups. I'm going to go into this particular group of processes, and I already have this built up here. So, but to give you a sense, how NiFi talks about having little components, NiFi has a bunch of components already written. And they all do one thing. Typically, they try to do one thing and one thing well. So we're going to have one that does get HTTP. So we find this get HTTP component. I just search for it. It's 172 of these things. I add it to the canvas. It's not ready to run yet. It's ready to be configured. Everything in NiFi gets configured. I can control click on this component. I get this menu that comes up. and I can see all the things that can happen in regards to this particular component, or process, or better terminology, the NiFi terminology. So if we looked at configuring it, the properties, each process has its own set of properties that are built when the process is built, when developed with the code. So they actually, all these things live in the actual, each individual component. To do a get HTTP, obviously you're going to need a URL. We're going to file name to assign to the file, so we're going to name the file. If SSL is used, then usernames and passwords, times out, all the things that you could think of that you might need in order to configure a get HTTP process. And once that's configured, and I've got one configured here, so we'll go look at this one. Once it's configured, so I'm going to go out to noaa.gov and pull the home page. It can be scheduled. So one of the other things that's really nice about NiFi, since you have these little independent components or processes, they can actually be run in parallel. So I can do concurrent tasks. In this particular one, when this one task is run and it finishes, it waits a second and then it runs it again. So there's also the ability to do, this is timer driven, it can also do cron if you're familiar with cron. So all of this processing can actually be scheduled. And it can be run continuously, all to generate streams of data, whether that's pulling from somewhere. So this is all about, you know, this particular process is all about a source of data. So you can name your components and some other configuration information, pretty straightforward. So I've got another one here called put file. So this is going to go get Noah's web page, an HTML file. It's going to write all of the HTML to that flow file. Going to put it into the queue, and then it's going to actually go to this put file processor that writes the contents of a flow file to the local file system. So I'm going to start this up. So currently it's gone out, the process has started, it's been scheduled, the processor is currently running, that's what the triangle means. And here in a second we should see, since I don't have this one running yet, this put file running yet, we should see something show up. We should see a flow file show up into this queue. And it takes a second for it to refresh, so I'm going to go ahead and list the queue. It's there. And now we can look in. So now I'm looking into this connection. This is a buffered flow file, and I'm going to go look at this. And this are the attributes of this particular flow file. It's gotten a UUID, so it can be it's keyed via UUID. It doesn't have a lot of attributes, but it does have that file name that we set up. It does say that it's HTML. And so this is the attributes of the flow file that live in the flow file repository. So this is the metadata that can be utilized and changed a lot without much. When I click this view, it's actually going to go into the content repository and pull out the bits from the actual payload that was taken. So if I go into there, there's no viewer for this, so I'm going to have to look at it in hex. And if you look over here, you'll see the hex. This is actually the binary of the NOAA web page that we just pulled. So that is basically the simplest flow that I could develop, just to give you a sense of the pieces. Processor, connection, and if I actually ran this here, it would actually pull these out and write them to the file system. So you could get possibly how that works. Okay, so simplest flow file ever. I'm going to go back and we'll go look at a more interesting one here in just a second. So now let's look at what this real use case that I've come up with. So this is kind of the setup to look at a more complex flow that we'll look at here in just a second. Social competitive intelligence. This is an example. I'm going to take filtered Twitter streams. So I'm going to filter. So I've signed up with Twitter. NiFi has a built-in processor called Get Twitter Stream, and it takes you can actually send it some filters. So like when I say filters, you can filter on the tweets just like you would when you search for a tweet. So I've got one set up for AWS, one for IBM, one for Google, and when I say all for their cloud stuff. So we're going to take all the cloud tweets that we can find. We've bucketed them and labeled them with their particular stream that they came from. We extract some attributes. Then we send the tweet itself, the text of the tweet, to Watson for sentiment analysis. So this is a custom processor that I built in Node.js. I wanted to go further and productionize this. I could actually carry it over into Java. And if you look at one of the blogs that I've written, I actually do show you how to write a Java custom processor too. Once we get this tweet back scored with sentiment analysis from Watson, we're going to send the score itself with a good key into Redis. So this would be kind of halfway there to delivering the data that you could use in some kind of a dashboard if you had some kind of a soft real-time visualization web page that you wanted to build. You know, Redis is good for that kind of hot data. So we put some of that basics of that metrics in there, and then we store the full tweet with all of the new sentiment analysis right into Mongo. So let's look at that. So back in NiFi now, I'm going up to my process groups here. This is, I'll scroll out a little bit. So this is the actual full flow of pulling multiple tweets, tagging the tweets, merging all of the streams of the connections into one, and then actually I've got them buffered here and stopped right before getting score sentiment. So this is where I take each of these individual tweets and actually going to send it off to Watson, to the Alchemy API, and do some sentiment analysis of the actual tweet itself. So real quick, I'm going to go in here and I'm going to look at a tweet just to give you a sense of this raw data. So once again, I've got attributes. These are flow file attributes. This particular tweet I've tagged as Google. So now I've got that into the system. I'll be able to utilize that information. I'm going to go look at the actual flow file content itself. I go into the view. This is the actual the actual payload of that particular flow file. Well, what we're going to do, and I just picked this one by random, so this one has GCP in it, so that's how it got picked. So this tweet might not have anything to do with Google itself, but it did have GCP, Google Cloud Platform, in it, so it did pick it up. Anyhow, this text gets sent. So this is the text of a real tweet. This data set here comes directly off of Twitter. And so when we send this stuff off to Alchemy, when I send it off, I just take the text out of this because I parse into the JSON. The other piece of information that I'm going to use to create a score is this followers count too. So the other thing that I put into Redis is if you have an actual tweet, I actually created this is a rather arbitrary score on my part, but it said reach. So a user that has 20,000 followers that retweets something gets a score of 20,000, whereas if you've only got 40 followers, you get a score of 40 for that particular tweet. So that's the data that gets sent and gets scored, and then when it comes back from that scoring process, it actually gets sent into Redis and Mongo. So I've got Compose's data browser open here, and so I don't know if you haven't used Compose before, this is actually a data browser into Mongo collections. The collection is not even created yet, and this one here is into a Redis Redis database, and I don't have any keys yet. So I'm going to go ahead. I've got 760 tweets queued up. I'm going to go ahead and start this process here. So what's really cool about NiFi is you can stop pieces along the way, and they'll queue, and it doesn't hurt any of the data. I haven't lost any data. It's still all written to disk, and now I can start it up, and it'll start to flow through. So as this starts to flow through, we'll get to see some of this data populate into both Redis and into Mongo. So already I've got 8 tweets that have all flown into Mongo. So this is post-processing from these are tweets that have been put into Mongo that have been already processed by the Alchemy API. So this was the actual tweet about their Microsoft and their Slack competitor, AWS startups, something there. This particular user had follower count of 1,039, so that When we go down here, we'll see some scores. So this tweet was scored as negative by Watson. The category was AWS. I actually gave, this is a minute bucket via the Unix epic. So I just took the timestamp and divvied it out to create buckets, because I'm going to put because when I put it into Redis, I keyed it with the category, which was AWS. It was a sentiment score, and it's this minute bucket. So actually in Redis, I keyed all of the sentiment scores and put them all together by minute. So when we go over here and look, we'll see a bunch of keys. And this particular, so Azure was the label, a sentiment score, and this was the minute bucket. So this is a typical type of key, complex key into a list of sentiment scores for that minute. So these were you could take this now and do some simple visualizations, maybe even some averages or those types of things. So all of those came together. The last thing that I want to show before I run out of time here, this particular process is called execute stream command. And this is, when I work with NiFi, one of the things that I like to do before I spend a lot of time building a custom Java processor, I actually kind of flesh out my ideas in Node. So this execute stream command takes a standard in. The standard in is a flow file. So each particular flow file, the command gets called, the standard in becomes the content of that flow file, and whatever you put on standard out becomes the new flow file. So that's how I manage this particular calling into the Alchemy API, because there isn't one of those built. So I'm going to show you that code here real quick. So it's just a simple npm node package, and just to give you a sense what's in the dependencies here. I've got Watson Developer Cloud I depend on. I depend on Redis because I use this also to put to Redis since there's not a Redis, and just some simple config. For ease, one of the nice things about npm is you can create some commands by these bin commands. So I've got get sentiment and I've got put Redis. So that one process that was the Alchemy process is called get sentiment. So we'll go look at that real quick. So this is the complete NiFi extended custom process that actually interacts with Alchemy and scores via that text from the tweet. So a lot of this is just boilerplate to get set up, config stuff, require the Alchemy library, get an Alchemy key. I've got that down in just in a config file. Like I was talking about, standard in. So we use process, just the regular process standard in. While it's readable, we build up the flow file because you can get more than one of these because it comes in and you got to fill the buffers and then you can fill your entire flow file. When that ends, then you know you have a complete flow file, so you've got everything. So this is where the real work is done for this particular process. Not too much to it. I parse the flow file, so now I've got a JSON object, JavaScript object, excuse me. I call the sentiment API. What's really interesting is a Twitter, each tweet already has a text attribute. The sentiment API requires an object that has a text attribute. So I send that whole thing in, and it uses that text attribute, and when it comes back, the response has the score. So response.sentiment score, I turn it into a number and store it into this original flow file object that I've got, and then I stringify it, send it out, and right here, when I send it out, that actually creates the new flow file. So this whole process here is extended NiFi, even with all of the semantics and guarantees of writing to a file, of managing it through the multiple processes. All that still works, and this is just with Node. You could do this with Python, you could do it with Go, you could do it with anything, because it's just using basic shell commands. And then when you actually have it to something that you really want to productionize and have more than just one output, maybe you've got multiple connections and want to do some failure handling and that type of stuff, at that point you really should probably look at doing something more in Java. All right. So extending NiFi, we just went over that. This was the execute stream command. They do have something called new execute, which is an execute script, but it's more based on the JVM type stuff. And then you can actually create and deploy your own processors and basically your own jar file. And NiFi has got its own custom class loaders, so you don't get dependency problems and that type of stuff. So, and if you want to know more about that, please do go look at the blog, because I did write a blog on extending NiFi with Java. Some resources, so this will be available, like I said, articles. These are the NARs. The docs on NiFi are great. And then I do highly recommend this GitHub too. This person here keeps a whole list of resources in regards to NiFi. So hopefully you found this a good, quick introduction to NiFi, and maybe it'll become a good tool in your toolkit. And I think that is all the time that I've got. So John, I think that's it. And thanks everyone. I appreciate your time. If there are any questions, I'm happy to ask them. If not, cheers.
All right, let me pull up my window. All right, now's the time. If you have any questions, please go ahead and post them in the question window. I did have one question, which is, can NiFi be used for data modeling?
For data modeling, no, I can't envision exactly how you would use it for data modeling. There are some processors, like some Avro processors and such like that, that'll actually read some data models from some source systems and keep the metadata in regards to, like from a record format into it. But there's really not like an ER diagramming tool where you're actually doing data modeling itself. So no, this is more about the movement of data around. And as far as NiFi is concerned, once the data hits that content repository, it's really just a blob. We were looking at formatted JSON there, but that was just a nicety of the tools. As far as NiFi itself is concerned, it's just bits.
Okay, great. And one other just came in, which is there any kind of data loss concerns when you change or update an existing data flow, I guess, midstream?
So the data, when you say a lock, like all that, I took that to mean more like versioning.
Sorry, loss. Maybe I mispronounced that. Data loss.
Oh, data loss. Oh, NiFi does a pretty good job in regards to managing data. So data loss it's pretty transactional unless you do something where you configure it not to be. Now, so every one of those tweets that we saw flowing through this system is actually the original tweet, and anything that was changed or written to was done. If it was changed, there was a copy on write, and there was a whole new version of it written to. So you, not only do you have the original, you get the steps along the way. And I didn't show the provenance repository. You can actually go back and look through those steps and see what changed when and that type of thing. So all of this is predicated on steps that write things to disks. So every one of those processors, when it writes a flow file, it basically commits a session, which is very akin to a transaction. So it says that it's written to disk, and then it returns. So if there was a change, that's what happens. So that happens in the metadata. So that flow file metadata that has the write ahead log, it commits to disk, and if it goes away and it comes back up, it'll repopulate memory, and then the content it won't commit back that it's done until it's written to disk too. So it's pretty good about protecting your data as it flows through. That's really one of the core points. And not only that, it can do that at scale too. We didn't even talk about scaling this out and clustering this. You can get into this where you have a zookeeper and a master and slave nodes and have multiple servers. So like I said, this came out, this was used in the NSA for 8 years, and they weren't pushing little bits of data around, and they cared very much about keeping it too, and it shows in the product. So yeah, data loss is managed pretty well. Better than any tool that you'd write yourself, other than maybe some transactional data store. But even then, like a Postgres or something. But yeah, it's pretty good.
Okay, one last question, which is, how is the auth handled for Twitter, and would it be the same for Facebook Graph/Atlas API?
You have to say that again. I didn't get it.
Sorry. How is the auth handled for Twitter, And would it be the same for Facebook Graph or Graph/Atlas API?
Yeah, each processor has the ability to be configured to do its own thing. So, like when we had that get HTTP, you could have set up SSL, and then it would have used the Java JVM normal infrastructure with key stores and trust stores in order to actually handle that. And then on the Twitter one, each one of those, and I didn't show it just because of time, in the how we configured the file-based processor, you configure the get Twitter processor, and it has places for all the keys. So if you go to Twitter and sign up for the developer access, it gave you all the keys. I'm assuming that Facebook would have something similar. I have not hooked that up in particular, but if it doesn't exist as a NiFi processor, the same way that I just did that Alchemy API, you could do something very similar. So that Alchemy API doesn't exist as a built-in NiFi processor. So that screams to, hey, let's extend this. And in that, I just used the keys and the library that Alchemy that gave me. So you could build your own custom one very easily. And once you wrote the flow file and it hit disk and it said it was done, then it's entered the system and it's there. So I don't think there's a real big barrier there, personally.
Okay,
obviously,
great.
some custom work. I mean but that's that's just because I'm not familiar with the Facebook Graph API.
Okay, great. I put up the questions screen, which has some more information. So if you go to compose.com/articles and search for NiFi, you'll see, I think, a 3-part series that Hayes wrote on NiFi. So there's more detail there. And also, if you have any just general questions about this webinar or anything else at Compose, just email us at webinars@compose.io and we'll forward that along. And there's no other questions, so that's the end of today's webinar. Thank you very much for attending. That concludes our presentation. Please do come to our our website to learn more about NiFi, and you'll find it on our articles page. And we will email everybody shortly with a link to today's recording. So anybody who registered will receive that. Thank you very much.